Coal Pollution in Kentucky by Hannah Allen and Patience Ferguson. In Kentucky, all 14 power plants covered under federal coal ash rules appear to be leaching coal ash pollutants into the earth. The problem isn't unique to Kentucky. All over the country, the Environmental Integrity Project has documented unlined coal ash landfills and ponds polluting underground water. Some emissions from burning coal are sulfur dioxide, which contributes to acid rain and respiratory illnesses, nitrogen oxides, which contribute to smog and respiratory illnesses, particulates, which contribute to smog, haze, and respiratory illnesses and lung disease, carbon dioxide, which is the primary greenhouse gas produced from burning fossil fuels, like coal, oil, and natural gas, mercury and other heavy metals, which have been linked to both neurological and developmental damage in humans and other animals, fly ash and bottom ash, which are residues created when power plants burn coal, and as stated as before, air pollutant from coal-fired power plants includes sulfur dioxide, nitrogen oxides, particulate matter, and heavy metals, leading to smog, acid rain, toxins in the environment, and numerous respiratory, cardiovascular, and other effects.
There are 3 solutions for coal pollution. 1. Clean coal. This is a process of carbon capture and sequestration, or CCS. This involves trapping the carbon pollution emitted as a byproduct from coal-fired power plants and sequestrating the stuff underground. Coal plants are the #1 worldwide contributor to climate change. Since coal emits much more carbon dioxide than its fellow fossil fuel mainstays, oil and gas, when burned, and since 30% of the world's energy is generated in coal plants, the proposition of hacking already existing coal plants to be a clean power source is an alluring one indeed. And 2. Coal gasification. Coal is best known for its role supplying electricity throughout the United States. Nearly half of the country's electricity comes from coal. But while the vast majority of it's burned at conventional coal-fired power plants, coal is also turned to gas for conversion into electricity, hydrogen, and other energy products. The U.S. Department of Energy explains that coal gasification is a thermochemical process in which the gasfire's heat and pressure breaks down coal into chemical compounds. The resulting syngas is comprised primarily of carbon monoxide, hydrogen, and occasionally other gaseous compounds. And 3rd, which is coal liquefaction, which we chose as most effective, is a process where synthetic liquid fuels from solid coal as substitutes for various petroleum products. There are 2 types of liquefaction, direct and indirect. Direct liquefaction converts solid coal directly into liquid form with no intermediate step, which results into only partially dismantling of the coal structure. Indirect liquefaction requires intermediate gasification of the solid coal to form a synthesis gas, which is then converted to a liquid product. This process results in complete dismantling of the coal structure. Simply put, coal liquefaction means converting coal into a liquid of some sort.
The first step in direct liquefaction is probably the thermal break-in of chemical bonds in coal macromolecules. The weakest bonds probably break first. Likely these are bonds between aromatic ring systems. The products are radicals. Radicals must be capped with hydrogen. Doing so produces stable molecules of lower MW than the parent coal. Repeated bond breaking and radical capping eventually produces molecules that are liquid.
There are 2 ways to liquidate coal, and first is hydrogen addition. Choice 1 is where you add hydrogen directly to coal. This is the process of direct liquefaction, and choice 2 is where you add hydrogen to carbon monoxide made from coal in a separate gasification step. This is a process of indirect liquefaction. Commercially, this is more successful of the 2 strategies. The second way is to do coal to petroleum-like liquids. Choice 1 is where you add hydrogen. This can be accomplished by direct hydrogenation or by solvent extraction followed by hydrogenation of the extract. Choice 2 is reject carbon. This can be accomplished by pyrolysis.
These are the citations from where we got our information.